right, guys, today we got the fundamental theorem of algebra, which is going to basically tie everything we've been doing together and add one little thing to it. So here we go. Fundamental theorem of algebra basically says whatever the degree is, as long as it's positive, that means there's that many solutions to the equation or to the function. Okay, so as long as you're including the set of complex numbers, which means you're including I, and also if they are double solutions, like let's say you get -2 two times, those count as two solutions. So one more time, whatever the degree is how many solutions we're going to get in the set of complex numbers, meaning I could be one of the solutions, two of the solutions, and also if the solutions repeat, those count as individual solutions. So basically, whatever the degree is, that's how many answers you got to find. All right, let's try. Well, the first one here says, how many solutions does this first one have? Well, because the degree is 3, it actually has 3 solutions. All right, so now let me show what they are. I went ahead and solved it, and the solutions were -3, 4i, and -4i. Now it has 3 because we could include imaginaries. Part B, how many zeros does it have? Now remember, zeros really are solutions as well. Because the degree is 4, it has 4 solutions. I went ahead and solved this one too. Look what they are. It's crazy. The solutions are -2, -2, -2, and 0. But even though the -2's repeat 3 times, they count as 3 different solutions. All right, this one says find all the zeros, meaning all of them. It includes imaginary, real, all the things. So what I'm going to do first is I'm going to make my list like we did last week. So I'm putting the factors of the last number, which is 8, over factors of the first number, which is 1, 1 over 1, 2 over 1, 4 over 1, 8 over 1. And I'm going to punch in my calculator and see where it crosses the x-axis. And it looks like when I do that, it crosses a 2. So I'm going to try a 2 first. I'm going synthetic. You got to prove it, remember. You can't just like, oh yeah, it looks like it does, so it works. You have to prove it using synthetic. Bring the 1 down. 1 times 2 is 2. Add them up. 2 times 2 is 4. Add them up. 10. 2 times 8 is 16. 4. 2 times 8 is 0. Yes, it does work. Now, because I still have a lot of numbers down there, the 1, 2, 5, 8, and 4, I'm going to use that to break down some more. I'm not ready to factor that yet. That's way too many. So looking at my graph, it also crosses at -1. Touches at -1, looks like. So I'm going to try -1. Bring the 1 down. -1 times 1 is -1. Add them up. Multiply, add them up. Multiply, add them up. Yep, looks really good. Now, I still have a bunch of numbers down on the bottom. So I'm going to do one more. Actually, I thought might would factor, but let's just do this. Because the graph actually did not cross the x-axis at -1, but it bounced off of it or just touched it, that means -1 probably, it does, it counts twice. So let's try the -1 again. Bring the 1 down. -1 times 1 is -1. Add them up. -1 times 0, bring it down. -1 times 4, yes. That leaves me x squared plus 4. So here's what I have x squared plus 4, that's what I got left down there, equals 0. If I move the 4 over and take the square root, I get plus or minus 2i. So I get those answers, this one, and this one. So all my zeros would be 2, -1, and plus or minus 2i. But -1 actually counts twice. You know, I think we could do this. Sometimes we could put -1 as a DZ for double zero, and then plus or minus 2i. And there's my 5 answers. I knew I was going to get 5 from the beginning. So going to be a little bit of work today. All right, the last thing they're going to have you do is go backwards. They're going to tell you what the zeros are and make you come up with what the solution is. Now, 3 plus I, if 3 plus I is a solution or 0, that means 3 minus I has to be. Remember, they always come in conjugate pairs. So we're going to have to write them as factors. It's going to be a little bit of work too, so hang on. If 0 is an answer, if 0 is a 0, if 2, I can't talk today. If 2 is a 0, it came from here. It came from x minus 2. 3 plus I came from x minus 3 plus I. 3 minus I came from x minus. And we did this on the previous lesson. We're going to save that x minus 2 to the very end. First thing I'm doing is distributing the negative inside. So it's going to be x minus 3 minus I, x minus 3 plus I. And what I'm noticing is, again, saving this x minus 2, they both parentheses have x minus 3. Then they've got a plus I and a minus I, so they are conjugates. Don't forget how we do conjugates. We do FL, first, last. Well, the first is x minus 3. If you do x minus 3 times x minus 3, you get x minus 3 squared. Negative I times positive I is negative I squared. And we got to multiply that out. So if I square, multiply together, double, square, I get that. Now don't forget what negative I squared is. I squared is negative 1. So if I do minus negative 1, that's really a plus 1. So I have this. I have x minus 2. I have x squared minus 6x plus 10. Finally, I'm ready to do this x minus 2 in the front. So I'm going to distribute the x. I'm taking the x all the way through. I get x cubed minus 6x squared plus 10x. Now I can take the negative 2 through, getting negative 2x squared plus 12x minus 20. And now I'm adding that I can. I get negative 4x squared. I get 22x. And I've got minus 20. And there you have it. I would say something like, that's all you got to do. But I'll admit, it's a lot. All right, so hang on there. And we'll work on it tomorrow and get you ready to do well on it. All right, so see you tomorrow.